Hi people, Mrs. Gerber here. We're already at part 4, and in part 4 we're discussing the carboxylic acids and the esters. Right, so let us start. If we look at carboxylic acids, we can see they are organic acids that have a carboxyl group, which is the formula C double bond O, OH, or commonly written as COOH. In a carboxyl group, an oxygen atom is double bonded to a carbon atom, which is then also bonded to a hydroxyl group. Right, the suffix then being oic acid. Now I put an here in brackets because I see that many textbooks write the suffix as anoic acid. So the general formula then being CnH2n plus 1 COOH. The simplest carboxylic acid is then methanoic acid, or also known as formic acid. So here you see the structure. There's one carbon, meth, then double bond O, OHH. So the molecular formula is HCOOH. Right. So let's go further and look at the structure where we have two carbons. Then it's eth. So this is then ethanoic acid. So we see as two carbons, the molecular formula then being CH3COOH. The common name of ethanoic acid is then acetic acid. Right. The next structure that we can look at is where we've got three carbons. So it's meth, eth, prop. Propanoic acid. So it is then propane, the E gets oic acid. The molecular formula then is your CH3, CH2, COOH. We can also write these two O's as O2H, right? So I've done it here in the next example where we've got four carbons. So it's but or but, or but then that we prefer to use the pronunciation as but. So it's butanoic acid or butyric acid. Now, if you look at the molecular formula here, it's CH3, CHH, CHH, COOH. So a shorter way to write it then is your CH3, the CH2 in brackets 2 to show that it is twice, and then CO2 to actually add these two oxygens, you write O2H. So this is an example of propanoic acid and butanoic acid. Right, let's look at another example. Okay, now we've got the esters. So let us just go back to this. We can also see that this also forms a homologous series. All right, so all of these functional structures form a homologous series, and we'll discuss it here at the last slide. So looking at the esters. Now the esters, if you recall the alcohols and the carboxylic acid that we just did, you'll see that the ester is a combination of an alcohol that reacts with a carboxylic acid. So the name of the ester is then a combination of the name of the alcohol and the carboxylic acid. So we see the hydrogen here from the hydroxyl group, the alcohol, and the OH here from the carboxylic group forms water. Right. So you get the hydroxide here and you get the hydrogen here. that forms water. So that when we do the ester compounds now, we're only writing this part down because of the two H's and the O that form water. We don't write plus H2O, right? So we're only concentrating on this part when you look at the structure of the ester. So let's see how the ester is formed then with the alcohol. The alcohol being on the side, we've got the O, and the alcohol's suffix was ol. So the ol then changes to il. So here's one carbon, so it's methyl. Here we recognize the double bond oxygen, then being part of the carboxylic acid. And here's also only one carbon with a double bond. And then we know that the suffix of the ester now is oat. There we wrote it down, oat. So the combination name of the alcohol with a carboxylic acid is then methyl methanoate. So the anoic acid is oat, or the oic acid, because it's actually methane, the E, that is replaced by oat. Right, so you must understand when we do the next examples now, that the two hydrogens and the oxygen, the hydroxide here and the hydrogen here, forms water. And that explains then the different equations. So if we look at carboxylic acid, the side on this side of the propanoate of the ester. So there's 3 A carbons here. So it's meth, eth, prop with a double bond oxygen. We recognize this as the carboxylic side. Now I've written the O here because it's in the equation to show that is where the water is formed. This part with the oxygen here, with the O, is part of the alcohol. Now, this alcohol structure's also only got 2 carbons, so it's eth. And we remember the ol becomes il. So it's ethyl propanoate. Now you have to recognize now by now that when we form the ester, we first write the name of the alcohol, and then we write the name of the carboxylic acid, and together the suffix is then oat. Right, the next example where we recognize this then also as the carboxylic acid because of the double bond oxygen, and there's only 2 carbons, so now it's eth. And here we've got the alcohol with the O, this is the alcohol, so it's meth, eth, prop. The ol becomes il, so propanol becomes propyl, and the ethanoic acid here becomes then ethanoate. Together it forms the ester. So when we do the molecular formula, then you'll see that you've got your 2 carbons plus your 3 carbons here. So it will be then C5, right? And you multiply the 5 with 2, 5 times 2 is 10, it will be H10. So this is how you can recognize it. This is also C5H10, if you count all the hydrogens. So the number of carbons, which you count from both sides, the prop and the eth, right? The prop being 3, the eth being 2, that gives you 5. You multiply with 2, and then you get your number of hydrogens. Right, let's look at the next example. So the next example shows your hydroxyl side again, your carboxylic side again on your left-hand side with your double bond oxygen here. And now we've got 4 carbons, so it's but. Right, your alcohol only being 1 carbon, so it's meth. But the alcohol, the ol, like I said, becomes il, so it's methyl. The but here, right, gives the collective suffix of the ester, the OAT. So the carboxylic side has got an OAT in the ester, the name of the ester. So it's methyl butanoate. Again, here you can see there's 1, 2, 3, 4, 5 carbons. So if you, without counting, you can know that there will be 10 hydrogens. So it's C5H10O2. Right, so we'll discuss that now in further on in this part of 4. So let's look at the next example. Right, immediately you recognize this is your carboxylic side because there's a double bond oxygen. So it's 1, 2, 3, 4, 5 again, right? So it will be pent. Here you've got your alcohol with 2, so it will be eth. So it's ethyl pentanoate. Now, obviously here it's 5 plus 2, that's 7. So it's C7 times 2 is H14O2. And you can check, if you count your hydrogens, you know it will be 14. If you drew your structure correctly, it will be 14 hydrogens. And then obviously your 2 oxygens. Right, let's look at the next example. Oh, right, I use this example to explain the general formula of the ester. All right, so if you look at this, again, here is your immediately your double bond oxygen. So this is your carboxylic side, and this is your alcohol side. Now they both, the alcohol has got 1 carbon, right? So it's methyl. And then your carboxylic side has got your 2 carbons, so it will be eth. So it's methyl ethanoate. But the general formula is written as RCOOR, right? So the R here represents these hydrocarbons here, or the carbon with the 3 hydrogens, right? So the R generally stands for the hydrocarbon chains, or the chain in this example, or they also use the definition as any group of atoms. It can be any group of atoms. So in this example, this simple example that I drew here, you can see the C is that one, the 2 O's, and then the R is any of the atoms representing the rest of the molecule. So your functional structure here is your COO. So let us look at this. We have now noticed that the naming of the ester, the first part is derived from the alcohol name, right? I've done it in all the examples. I've put the focus on that. And the second component is the name of the ester is derived from the carboxylic acid, right? We've done it in each example. I've shown you that. And then the general formula, like we just explained here, is RCOOR, where the R can refer to the rest of the molecule. Whichever IUPAC molecule you are using is represented then by the R. And we know the number of carbons here. We see it's 3. So it's meth, it's 1. Plus 2 is 3. So if you write the molecular formula down of this, you'll know that is then C3H6O2. Okay. And it forms a homologous series. And we'll look at that example now. So it's important that you do understand why the general formula is written as RCOOR. The COO being this part, the functional part of the structure of the ester, and the R's representing the rest of the molecule. So I hope that is clear to you. Right, here I've written down the examples that we've discussed in this part A4. Now, if you look at this, before you look at the molecular formula in total, if if you look at the hydrogens here, let us look at C2. So it's then 2 times 2 is 4, like we said. So if you would put in C3, it will be H6. C4 will then be H8. C5 is H10. So you can write C here, C5H10, C5H10. Now then C6 will be H12 and C7 is H14. And obviously the O2s must not be left out. So an easy shortcut to make sure that you've written your molecular formula correctly is that you count in the name, the IUPAC name. You just double check your carbons. We know meth is 1 carbon, meth is 1 carbon. So 1 plus 1 is 2. We know eth is 2. We know prop is 3. So 2 plus 3 is 5. The same here, prop is 3. Eth is 2. So 3 plus 2 is 5. The same here, meth is 1. But is 4. So 1 plus 4 is 5. Here, eth is 2. Pent is 5. So 2 plus 5 is 7. So you know what, if you are very specific in your structures, you can have all these checkpoints to make sure. And so strive to get 100% for organic chemistry. If you understand the basics, it's actually super fun to do the structures. Right, so I really hope this is clear to you. So now for the practical exercises we can do in part 5. So I'm looking forward to see you in part 5, where I'm going to take out examples from previous tests and exam papers, and then I'm going to add the chains and the substituents. And then we'll have to identify the longest chain, and we'll have to recognize all the attached chains as part of the prefix. We'll have to recognize your ground word, the essence of the structure, what is the root word, and we recognize then the suffix as part of the functional group. So in part 5, we're going to conclude everything. We're going to use part 1 to 4, and then do the whole structure with all the, we acknowledge everything that must be in the prefix. We look at the root word, and then we acknowledge the suffix. So I'm looking forward to do that with you. You may use all the parts 1, 2, 3, and 4 and revise them and understand where they came from. And I'm glad that I could have shared this with you.